user. So the thing with analytical geometry is you obviously know that you'll be working with the Cartesian plane, right? Cartesian plane. So you want to be comfortable with how a Cartesian plane works. You see, a Cartesian plane basically just has coordinates. Oh, yeah. Yo, good Lord, come on. Excuse me. I was like, this thing. Yeah. So this is like the x-axis, y-axis. And then, so the idea is obviously, whatever you're going to be doing on the on the Cartesian plane, right? We know with analytical geometry, you have like a list of formulas that you need to work with, because on a Cartesian plane, it all starts at a point, you see, a specific point. On its own, it's useless, you see. You can have, let's say this is like 4 coordinate 2. On its own, it's useless. But the moment you have another point, let's say somewhere here, this could be like maybe -2 coordinate -3. The moment you at least have 2 points, now you can connect them and end up with like a line, you see, which is where things start to pile up now, you see. So from here, we know with analytical geometry, you need to be able to work with clearly points, see, points / coordinates. And then once you know how to work with just points, which everyone does, you see, x value, y value, as long as you know how to do that, I mean, in terms of labeling different points, it really doesn't matter. If you want to call this x1, you can. You'd have to call this one y1 though. If you want to call this x2, you can. You just need to call this one y2. So that's just coordinates, you know. But then the moment you have points / coordinates, I mean, if you start joining them, you're gonna have a straight line. You see, straight line. Now, the moment you have a straight line, now you can now get different properties of that straight line. So with a straight line, we know you're going to have an equation, which is just, let me not write it like that. Let me just write, with a straight line, let me put equation as a mini heading. With a straight line, it obviously has an equation, right? Which is y is equal to mx plus c. Now, obviously, what we already know is that m is the gradient. Now, the moment we think of gradient, we need to think of a formula, you see, which is now how analytical geometry works. It's basically a formulas game. So in grade 12, fortunately, most of your formulas, if not all of them, for analytical geometry, they're practically on your formula sheet, like all of them. So you don't need to like cram anything or nothing like that. So even like going through this, it's okay, you know. If it's been a long time since looking at this, then this is useful. So equation of a gradient of a straight line or any gradient between 2 points, we know that this is the formula because you have 2 points to work with. That's going to give you the gradient. Now, normally when you need to get the y-intercept, you will just need to use a different format, you see. So, which is this format, y minus y1 equal to m x minus x1. So this here is just a format you can use to get the full equation of a graph. Now, what you need here, let's say here, working out the equation of a straight line. So if you're going to work out the equation of a straight line, clearly you can see you need 2 things. You need a gradient, which has a gradient formula, and then you need a y-intercept. So normally when you want to get a y-intercept, you just use this format, because this format, it allows you to throw in a coordinate that the graph passes through. So here you're going to throw in a coordinate that the graph passes through, a y value and its x value, you see. And then here you are going to throw in the gradient. So you need 1, 2, 3 when you're working out the equation of a straight line, a point that it passes through and the gradient. So now that we're still talking about gradient, right? We need to be careful, because when it comes to gradient, we need to think of other ways that the gradient can be worked out. So with gradient, let me put here gradient. So you can either use gradient formula, you can either use the formula, or let's say gradient formulas, you see. So we have this one that we just mentioned now, m is equal to y2 minus y1 over x2 minus x1. That's one of your formulas. Another one, let me just do it like this. Another one is just knowing that the gradient of one line is equal to the gradient of another line if they're parallel. If the lines are parallel. Thirdly, you want to remember that the gradient of one line multiplied by the gradient of a second line will be equal to -1 if they are perpendicular. And you see here, you don't have to be writing this down because you're going to have it anyways, you see. So you don't have to like work twice, like trying to hear, trying to write, trying to cram, whatever people do, you know. So let's see here. Yeah, this time this is got -1 if they are perpendicular. Perpendicular, you see. Yeah, so M1 is perpendicular to M2. Here, M1 is parallel to M2. No, that's not accurate. This is also not accurate because M1 and M2 represents the gradients. What I wanted is maybe like let's say the line was AB or CD or something, then you can say AB is parallel to CD. Here you could say AB is perpendicular to CD. But this should be good enough. 1, 2, 3 formulas. But there's a fourth one. The fourth one is when you have an angle of inclination. Tan an angle is equal to M, you see. So here, this will always be an angle with the x-axis going anti-clockwise, anti-clockwise, anti, whatever works for you.
Either one.
Yeah.
But exactly.
Yeah. So what I mean is, if you have a Cartesian plane, the angle with the x-axis is always the angle going anti-clockwise. So you're gonna have the x-axis here, right? And it's gonna go like that. You see, so this is going to be your angle of inclination. You see, it's called the angle of inclination. So you angle with the x-axis, and then let's put in brackets here, angle of inclination. So you can see it's quite, you know, is a lot. Different ways to get gradient. You can use this. If you have 2 points, you can just look for parallel lines. You can just look for perpendicular lines, and you can just try and see if, you know, you have an angle of inclination. So you see, we're still just dealing with the straight line, 2 points, and we just spoke about gradient. But because we're dealing with 2 points, it then brings into mind other aspects of these 2 points, which are things like the distance between those 2 points. And let me just draw a new picture. It's, you know, when you have 2 points, you can now think of the distance between those 2 points. You can then think of the midpoint between those 2 points as well, you see, which are all just formulas. So if you have a point over here, point over there, this is A, this is B. Why did I draw them so close to each other like that? Let me do it here. Zoop. Okay, guess we're gonna have to replace you there. So A and B, we know we spoke about gradient, whatever. But as long as it's aligned, right, we will always need to at least get the distance of the line. You see, the distance, it has a formula. You see, distance, this is also on your formula sheet. It is equal to, what is it equal to? It's equal to square root, and then it's like x1 minus x2 squared plus y1 minus y2 squared. So the fortunate thing is, it doesn't matter if you write the x's first or the y's first. It's a choice. But then they just need to
Okay.
match. You see, if you have x1 and x2 here, you just would also have y1 and y2
Y1
in
and
that
Y2.
order. Yeah. And then you're always minusing. So just remember that, and then you're squaring there. So that's the distance, you see. However, between those 2 points, you know that there are cases where they could ask for the midpoint. See, midpoint. So with the midpoint, you actually usually want to look at it as 2 separate formulas. So let's put it this way. So here you have an x value and a y value. Let's not label it y1 and y2. I mean x1 and x2. Let's just label it x and y. But then the others here, let's label this one x1, y1. Let's label this one x2, y2. Just don't, so that they can be distinguished. So with the midpoint, obviously you actually want to always keep in mind that it's actually 2 parts. So the x value of the midpoint is actually equal to x1 plus x2 over 2. And then the y value of the midpoint is just y1 plus y2 over 2, you see. So the reason I'm doing it like this is because you want to recognize that with each of these formulas, you always have 3 slots. There is slot number 1 to put in something or work out something, slot number 2, slot number 3. So they'll either give you 2 of the 3 things here. Then they can ask you for any of the other ones. Same here, they can give you any of the 2, and then they'll ask for the third one. What I'm trying to say is they won't always just ask you for the midpoint. So they won't always just ask you for the midpoint. They
It
might
won't be
sometimes,
straightforward. Okay.
yeah, sometimes they can ask for the other side, meaning they can give you the midpoint and one side, meaning you need x2 and y2, you see. So if you need x2 and y2, then it means that you'd be looking for x2 over there, y2 over there, using 2 separate formulas, because you can see here x would have been given, x1 would have been given. So you would have been able to like throw those in there. And then here, y1 would have been given, y would have been given, so you'd have been able to throw those in there. And then that brings us to when your different points start to draw shapes on your Cartesian plane, you see. So it's just going to be, you know, things being added. So when your different points start to draw shapes, you would need at least 3 points, you see. 1, 2, and maybe 3. So when your different points start to draw shapes, the first shape that can come about is a triangle. The famous triangle. Triangles are like everywhere in math. I wonder what's so special about triangles though. Like they're literally everywhere.
Illuminati.
Ooh, what a wow. But then in the real world, I don't think we see many triangles really, you know. That's like the one thing we hardly ever see, unless it's in like construction or engineering or whatever. But oh well, let me not hate on the triangles, the holy trinity. So let me see here, what must happen. Yeah, so if you're gonna now work with a triangle, yeah, you just need to be careful when you work with a triangle, because not careful as in it's extra or whatever, but when you work with a triangle, you have to remember that different cases now can be, you know, created. You know, when you work with a triangle, you want to remember that you need to at least be able to work out the area of a triangle, which you can normally just use half base times height actually. The only issue is being able to recognize different sketches where you would need to recognize what's the height, what's the base. Now, in different kinds of questions, right? They can, the thing with math, right, is that there are different ways that they can, you know, eventually ask for area. Let me give a sketch that I can think of right now. So sometimes you'll have maybe something like this, and then you'll have maybe a line like that, and then maybe something like this, you see. So say you have this point and the point under it. Let's say here they have told us that this is the y-axis is parallel to this line. Let's name this line AB, see, and then here C. So it doesn't, so let's say they've given us coordinates, right? Let's just put random coordinates here. This x value and this, the x value of n b would need to be equal. So let's say 2 here and 2. Let's make this one a 5. Let's make this one a 1. And then here, let's make this like negative 3 and negative 6, you see. So if you have a shape like this, they can easily ask for the area of this shape. And on your side, you need to be able to work out the area of this shape using half base times height. What you just need to be able to recognize is how with a triangle, for you to get half base times height, you always just need to look and see how you can work out what is the base, what is the height. But to make life easier, let me draw a sketch like this. Let me draw the different triangles, right, that we can work with when we use half base times height. So we'll draw the normal ones that everyone knows to work with, and then we'll deal with this third one, because this third one is actually the problem. These two are easy, because with these two, I mean, you can imagine getting the, I mean, if this is a right angle triangle, and if this is like just a normal triangle, what we already all know is that the perpendicular height is always a line from, like, I think they call it the apex, like just a tip on the triangle, and then you drag it down perpendicular to a specific line. That's the perpendicular height. So here, this is the apex, right? So if you drag it down, going perpendicular to a specific line, here you go. With a triangle like this one, right, an image that looks like this, it's one of the images that always used to throw me off, because I don't even know when or how long it took me to then see that, oh wait, that's the base, that's the height. So with a shape like this one, this is the apex, this is the tip of the triangle. Now the perpendicular height is the distance going down.
It's not down there at the bottom?
Nope, this is the perpendicular height. It's the distance from the tip here going straight towards the, it has to be going perpendicular to where the base is, you see. So you can see here, this is the base. If you were to imagine that this is like an imaginary plane, this is a, you know, flat surface, if you will, and then this is the perpendicular height, you see. But let me remove these dotted lines here just so that it doesn't make anything crazy. This is the perpendicular height because it's from the tip going towards a line. That's one of the lines of your triangles. You see, it doesn't have to be the perpendicular height is not a line that will be inside the triangle. If it is going to be inside the triangle, it's possible, meaning that depending on how you look at it, for this same shape, you could also say, okay, maybe the perpendicular height, if you want to look at this as like the apex, the perpendicular height has to be a line going this way, like that. You see, that's also possible. You see it?
Okay. Yeah, I see it.
Even for those shapes that we drew, these ones here, I mean, if you really want to make your life difficult, I mean, be my guest.
No.
Here you could think of
by all means.
Yeah, you don't have to, you see. But I think with this shape here, what I can just show is that it doesn't matter which point of the triangle you make, you know, the apex. Because it's just a matter of maybe imagining that your shape was like spun around or something. And now it's not like, you know, in its upright position. So here you could, if you wanted, you could look at this as the apex, and then this would be your perpendicular height. And it's all up to you, you see. But as long as wherever it's going, the line it's going to be perpendicular to, you need to consider that as your base. You see. So in orange here, we're going to label what, or rather, let's make it red, you know. So in red here, this would be your base. This would be your base. I mean, funny enough, with this one, it doesn't matter which one you make base and perpendicular height. It's all gonna work. Here, this would be your base. Here, this would be your base. And then here, this distance would be your base. You see?
Jeez, okay, yeah, I see it.
Let's just put base, and then base, home base. whatever that means, base, and then base, and then the other one, you can put height, 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 height. There you go. So now with our green triangle here, you would need to be strategic about it, because with your green triangle, just because of the way the sketch is aligned, or just because of the way the sketch is set up, logically speaking, you would want to make this your perpendicular height. And then you'd want to make this your base. See, because if you look at this shape, it's just, this is just like that, you see. It's just aligned in a different way. Yeah. So with a shape like this, you can see that here you'll be able to work out the distance here using the distance formula. And then here you can just compare this x value and the x value of A and B. So from C going straight there, you can already see that you will be able to see a distance there. This one is easy. From 5 going straight down to 1, the distance there is a 4. See? And then here from -3 going straight to a 2, the distance here is a 5. You see? So here your base is a 4, your perpendicular height is a 5. So your area is just half times 20, which is 10 units squared. Do you see?
Yeah, I see.
Yeah. So normally if you're just seeing these, you know, and it was still just starting off, it's like, okay, yeah, it might seem like a lot, but it all just works together. Yeah, no, it's I get you. I will not downplay it. It's okay. So for the other cases where if you now have more than 3 points, right, then the shape that comes out is going to be a quadrilateral. It does not necessarily have to be like a trapezium or a parallelogram. It doesn't matter, but this one does kind of look like a trapezium, but I didn't do that deliberately. Oopsie. Oops. Oops. It keeps coming out.
Hiccups.
Hiccups. Oh yeah, the hiccups. Yeah, sure, madam, sure. But I don't know if that's really something to be sorry about. Is it?
It happens when I'm nervous.
It's okay. Nervous. Oh, sorry.
Analytical geometry is making me slightly nervous, hey.
Okay, you know it's making me slightly nervous because I'm really like just dumping a lot of information. Like this is almost like the whole first 50% of the topic all at once, like legit. You know, so you can imagine 50% of the whole thing. That's a lot, you know? Yeah, it definitely is. It definitely is. It definitely is. So let me see here if what must happen. Oh yeah, so when you now have a four-sided shape, right? Nothing much really changes. It's just that with four-sided shapes, they have more to do. You know, they can have an angle of inclination there. They can maybe name this alpha, but then for you to get this alpha, you're most likely going to use this side of the sketch. You know, because this is the one where it's coming from the x-axis. Because remember we said this is the angle of inclination, and in using your formula, you're going to likely, whichever one you get, just think of it logically, because if you do get an acute angle, then it's this one here, because this is the side that's smaller than 90. But then wait, your answers will always come out as like what you call an acute angle, you see. So if you want to
you muted your side.
do this, stop.